All right, welcome to Notes on Imaginary Numbers and Simplifying Radicals. This is part one. We will start this today, keep learning it tomorrow. So first, let's talk about the simplifying radicals parts. The word simplify, to do some vocabulary, just means, let's change the color. I'm going to use dark blue, maybe make it a little bigger. To take an expression of numbers and change it to an equivalence, meaning the exact same thing, an equal expression that is typically smaller than the original. Whatever original expression you have, it's usually long, and you use all the math rules and you combine numbers together that you can, and you make it smaller. And that's the process is called simplifying. This time we're going to simplify radicals. So what a radical is basically anytime you see a little house like that little square root symbol is the one you know, but it doesn't have to be a square root because it could be like a cube root and have a little 3 there like that. It could also be a 4th root or a 5th root. Any type of little house root symbol at all, and that's called a radical. So that's what we're going to be simplifying. However, we're going to only focus on the square roots, and the square root's the one you know that has nothing right there. However, technically, it's not nothing, it's a 2. However, that 2 is so common that we don't write it usually, and the little house without anything there means it's a 2, which is why it's called a square root. So we're going to be simplifying those, but in order to do that, we have to talk about something called an imaginary number. So let's just get this out of the way. There are imaginary numbers. They exist. They are real. It is known as I. We'll talk about why it's imaginary, but it exists. And so we need to talk about some properties of I. Properties just mean basic rules. I works a lot like any other letter. For example, I times I is simply, let's see, I like to write my I's with a little curve to the power of 2, I squared. Oh, completely undo all of that. Silly me, that's not I times I. This is I plus I. And I plus I is really easy because there's 2 of them. There's one right there, plus another one means there's 2 I's. Then if I move on a little bit, right here, you see 7 I's minus 2 I's. If you have 7 and you go and you try to take away 2 of them, you end up left with 5 I's. So this works a lot like the X's do. So in the same way, if this is I minus 3 and I wanted to simplify that, well, this is an I, which is imaginary, and this is 3, and that's not imaginary. So you can't combine them together because they aren't like terms. So the answer is simply I minus 3 because you cannot put them together. Now this is the I times I part. And the I times I, as we talked about, there's 2 of them being multiplied together, which means the I gets an exponent of 2 because that means to take something and times it by itself. Now here is where I is interesting and what makes it different than any other thing that we have in the real world. I exist in the imaginary world because I squared is, need to change my color, -1. So the imaginary I, when you square it, becomes the real -1. So now that we understand the rules of I, we just need to be able to do arithmetic with I when we simplify. So let's start with one like this. This is 3I to the power of 5, which means we have a 3. and it's getting multiplied to an I, but there's 5 i's because to the power of 5 means multiply that number or letter 5 times. Oops. That's 3 times 5 i's. So remember, each I times I together is an I squared, meaning we have a 3. Oops, back to blue. We have 3 with an I squared. Use that for squared right now. I have another, so these 2 i's I used for an I squared. I have another 2 I can use for another I squared. There's another I squared. And then I'm still left with this 1 I at the end by itself. So each I squared, or I to the power of 2, the special property is that it's -1. So I can replace the I squared with -1. There's 2 of them, so I have 2 -1s, but I still have this I at the end. So now these -1s are real numbers, and they can combine with the 3. So 3 times -1 is -3, times -1 again becomes +3. So when I combine all those together, I get a +3, then 2 -1s basically cancel each other out, and I'm still left with that I. So my answer is 3i to the power of 5 when it's all simplified is the same thing as just 3i. Let's try this one here. So I have 2i squared. So I have a 2 times an I times another I, and then -5. But remember, these 2 i's, this I squared over here, is just -1. So it's really 2 times -1. And then I still have to bring down my -5. Well, 2 times -1 is -2. And then -5 gives me an answer of -7. Because if you owe me $2, then you owe me 5. Together, you'd owe me 7. So this expression up here that was imaginary, when simplified, became real. And now it's a real -7. All right. Then if I try this one right here, the first thing I have to do is this parentheses has nothing in front of it, so I can copy it just the same. It's just 6i minus 5. However, this parentheses has a negative in front, and that negative needs to go into both of those. So this +3 is going to become a -3i, and this +4 is going to become a -4, because I have to distribute that negative into both. Now I combine like terms. So I have 6i's right here, which can go with this -3i's. And 6 minus 3 becomes +3i. Then I combine the -5 with the -4. If you owe me 5 and you owe me 4, together you'd owe me 9. So now this is 3i's, and this is -9. And these are real numbers, and these are imaginary. So I can't combine them, so this is the most simplified they can get. Finally, to simplify this one, this is a parentheses times another parentheses, because there's no plus or minus here. Here there's a minus, so all I had to do is distribute it into both in the second one. Here it's a times, which means the method I need to use is my arrow method or my area model box method, but I'm going to use the arrows. So if I do I times 4i, I get 4i to this power of 2 squared. Then I have to do I times -7, which is just -7i. Then I have to do the 3 times the 4i, which is +12i. Then I have to do the 3 times the negative 7, which is negative 21. Now, remember I squared is negative 1, so that becomes 4. Instead of I squared, I'm going to put parentheses negative 1. Then negative 7 plus 12, they're both I, so I can combine them. And if you owe me 7, then you get $12. You're going to end up at positive 5I. And then I still have to bring down my negative 21. Well, 4 times negative 1 is negative 4. And I can combine this negative 4 with my negative 21 because those are real numbers, both of them. If you owe me 4 and you owe me 21, you'll end up owing me 25 when I combine those like terms. And then I have to still have this plus 5I that I can just bring down in front. So my answer is 5I minus 25. So this expression up here, parentheses I plus 3 times parentheses 4I minus 7, is the same thing as, after you solve it out, 5I minus 25. So now we have to combine the two concepts. Radicals with imaginary numbers. And here's how they combine. First of all, when we ask ourselves the question, what is the square root of 4? Square root means what times itself is 4. So the square root of 4 happens to be 2. Because 2 times 2 equals 4. But it has a second answer. There's also negative 2. Because negative 2 times negative 2 also happens to become positive 4. Because a negative times a negative is a positive. So what is the square root of negative 4 then? Well, now we're stuck because it can't be 2, because 2 times 2 is still positive 4. Also can't be negative 2, because in the real world, negative 2 times negative 2 is still positive 4. So here's the thing. In the real world, the square root of negative 4I, we don't know. If you go over to a graphing calculator, like Desmos here, and you try to type in, let's see, square root of negative 4. That didn't work. Oh, here's what I gotta do. Gotta use that. This is Desmos graphing calculator. When you're in Desmos, down here there's this little show keypad you can use to click up, and then you can see the square root button right here. If I type in negative 4, it's going to say equals undefined. It doesn't have an answer because you can't take the square root of a negative, not in the real world at least. So is there any number in the real world when multiplied to itself the outcome is negative? No, not in the real world. However, I times I is negative 1. So in the imaginary world, we can take the square root of negative 4. Because of imaginary numbers, the square root of negative 4 has two answers. It's 2I, because 2 times 2 is 4, and I times I is negative 1. And negative 1 times 4 is just negative 4. And there's negative 2I, because still the negative times the negative, watch, negative 2I times negative 2I. The negative times the negative will become a positive. The 2 times 2 will become 4. And the I times I will become negative 1. And 4 times negative 1 is still negative 4. Oops, negative 4. So both of these, both 2I and negative 2I, will give me the answer of negative 4 when I times it by itself. So the square root of negative 4 is both 2I and negative 2I. So when they tell us to simplify radicals, we have our goal. And our goal is to pull out, and I'll explain what this means. Pull out any number that shows up under the radical twice. But here's how it works. The square root of 4, we all know the answer is 2. We've talked about it, and it's negative 2. Because a negative times a negative just becomes positive. However, if I'm breaking this apart as to why it's true, besides the fact that 2 times 2 is 4, if I break apart 4, when I'm breaking apart a number, here's what you should do. You should think, what can I divide 4 by? Well, I could divide 4 by 1, but 4 divided by 1 is still just 4. However, I could divide 4 by 2. So the square root of 4, if I divide 4 by 2, becomes 2 times 2. When I break apart the number 4, it becomes 2 times 2. So 2's under here twice. You see that? So if it's under there twice, like this, it can come out in front of the square roots. So that 2, if it comes out in front of the square root, it looks like this. And in front of it, and under the square root, oops, come here. Oh. Under the square root, there's not a 4. Wow, it's not letting me do it. Under the square root is nothing. All the numbers are gone, and it won't let me, maybe if I put a 0 there. All the numbers are gone because both of these 2's, they came out together as 1, 2. So there's 2 under here, and the square root makes those 2 become 1 and come out front of the square root. So then there's nothing left in there. So you don't need to leave the root 0. You can just write it as 2. But sometimes there will still be things left underneath that square root, and that's just a part of the answer. So let's do a lot more examples. So the square root of 400 becomes, if I take 400, and I'm going to always start with 2. Can I divide 400 by 2? Well, let's see. If I do, come over here to my graphing calculator. If I do 400, and then divided by is the slash button, and then 2, it says the answer is 200. So 400 can split into 2 and 200. However, 2 is a prime number, and what prime means is that it can't split any further. It's the smallest it can be. And if you go to Calkins Math Section 1, at the bottom, there's a thing called Math Tools. Here's the calculator I'm using, and here's a list of prime numbers, which is this chart right here. And 2 is one of the prime numbers. You can't divide it into anything besides 1 and 2. Same thing with 3, 5 you can't make smaller, 7 you can't make smaller, 11 you can't make smaller. These are the first 100 prime numbers, actually, this little chart. So if you hit one of these numbers, you're done. You can't break it up any further. So 2, I can't break up any further. But 200 I definitely can. So if I take this, I can split 200. Let's divide it by 2 again, so another 2 shows up. If I do 200 divided by 2, I get 100. And look, now we have 2 2's right here. So these 2 2's can become 1 and come out. So it's not going to be under anymore. It's going to be in front. And then the only thing that's left inside is now the 100. But 100 we can still break apart because 100's not on this list. And so I'm going to break this apart even more. So I can divide 100 by 2, and I'm not going to show you, but you'd get 50. I messed up. Oh, no. So I'm going to divide the 100 by 2. And then it'd become 50. 50 is not on that list, and 50 can divide by 2 as well. So I still have the 2 in front, my little root symbol, the 2. Then if I divide 50 by 2 again, I get 25. So now here's 2 more 2's that can come out front. They turn into 1 2. So then it becomes, there's already a 2 there, so I'm going to put it in its own parentheses. Now another 2 is coming out front. And then left under the square root, I only have 25. So this, I can combine the two 2's in front now. 2 times 2 is 4. And then I have the square root of 25 still. 25 is not on my prime list. It can be broken down, but it can't be divided by 2. 25 actually is 5 times 5. Square root of 5 times 5. And now you see 2 5's under the square root. So those 2 5's can come out front. So I already have a 4 there. The 2 5's under the square root become 1 5 outside of the square root. And then now there is nothing at all left under that square root. So simplifying this, 4 times 5 becomes 20. You don't need the square root. So the square root of 400 is 20. That's the answer. If you come here, you want to skip all the work of why it's true. Square root 400 is 20. Look, that's the answer. However, you can't always use this calculator, and sometimes they're going to tell you you have to leave your answer in radical form. And what that means, if you try, like, for example, the square root of 54, if I come in here and put 54 in my square root, it's a decimal. And they won't want that. They won't want the decimal. They're going to want the answer in the radical form. So here's how you do it. I'm going to do it again. I'm going to go a lot faster, though. Square root of 54. If I divide 54 by 2, I'm going to get 37. Now I want to check that. 27. Haha. That's what happens when you try to rush. So can I break 27 down and dividing by 2? If you check the answer is no. 27 divided by 2 is a decimal. So then if I try dividing it by 3, I get 9. So that's cool. So then this will be the same as the square root of the 2's there. But I want to divide 27 by 3, and then it turns into 9. Oops. Make that look prettier. All right. So then 9, 3 is a prime number, so you can't break 3 down anymore, but 9's not. So 9, you can't divide it. Oops, wrong notes. You can't divide it by 2, but you can divide it by 3. So now you have the square root of 2 times 3 times 9 becomes 3 times 3. So there's at least 2 that can become 1 together and come out front. So I have the 3 that comes out front. And then there's still a 2 and a 3 under the root. So since there's 2 numbers left under the root, all you do is multiply them together to get your answer of 3 root 6. So the square root of 54 is the exact same thing as 3 root 6. And if you come here, you can see that in the calculator, the square root of 54 is the same thing as 3 square root of 6. See the decimals, 7.348, 7.348, exact same. All right. Let's do the next one. Más rápido. So this one has a negative in it, which will happen a lot. So remember that the square root of negative 32 can become negative 1 times positive 32. So that negative can come out and become negative 1. Then remember the -1, the square root of -1 is just I. Then you still have 32, which if I try dividing 32 by 2, I'll get 16. Then if I try dividing 16 by 2, I'd get 8. Then I have two 2's that can get smaller together and become 1, 2 and come out front. And then I still have the 8 in the middle. No, so I have 2I. Square root 8, if I try dividing it by 2, becomes 4. And then 4, if I divide it by 2, becomes 2, leaving me with 3 2's underneath, so 2 of them can join together and come out front. So I already have a 2, but now another 2 is coming out front. And then there's only 1 2 left underneath the square root now because 2 of them came out. And then when I multiply the 2 and the 2 together, I get 4I out front. And I still have the square root of 2 left underneath. And that is my answer. There's one thing to note that I have been forgetting to do on all of these, that it's not just 20, but it's also -20. So it's plus and minus 20. Plus minus. Plus minus. 3 root 6. This is plus minus because it's the positive version and the negative version because of square roots, and that's how they work. All right, so this one says root 20 times root 12, and here's the thing, because it's multiplying, it doesn't matter if it shows up under 20 or 12. If it's there twice, you can bring it out in front, and you can also just multiply them together. So technically, as we do this, it's the exact same thing as 20 times 12 is 240. So we're taking the square root of 240 technically, but they've already split it down by 20 and 12. And they just want you to take it from there. So you don't have to go backwards. You can just do it from 20 and 12. So if I do it from 20 and 12, 20, I'm just going to break it into all the parts at once instead of pulling them out one at a time. You'll see what I mean. So if I divide 20 by 2, I get 10. But I don't want it to be 10. I'm going to divide 10 by 2. And 10 divided by 2 becomes 5. 2, 2, and 5 are all 3 prime numbers. See, 2, 2, 5. You can't take them down anymore. So then you still have the times, and then root 12. And 12 becomes 2 times 6. And then 6, if I divide it by 2, becomes 2 times 3. And now, both of our numbers are completely broken down into only prime numbers. So anytime I see something twice, they can combine together and come out front. So right here I have 2 2's. I'm going to bring it out once. Then under my root, I still have that 5. Then over here, I have 2 2's, and I can just bring it out front. And I can combine them together because it's just multiplying. And then under that square root, I still have a 3, which I can put under this square root and combine them together. So then if I'm trying to combine them into one answer, 2 times 2 is 4. Then I have my square root. And then 5 times 3 is 15. Oh, and because it's square roots, it's the positive and the negative. That's my answer of this. So positive 4 root 15 and negative 4 root 15 is the same thing as the square root of 20 times the square root of 12. And that is how you simplify radicals. And if one of these were negative, there would just be an I on it. And that is how imaginary numbers come into play with this.